Hi, this is Greg West. I'm one of the instructors for ATSC 113 Weather for Sailing, Flying, and Snow Sports. Specifically, I'm one of the instructors for the snow sports section. Today, I wanted to talk a bit about contours and contour maps and how to interpret them. We'll start off by talking about the first learning goal in the snow sports section, which has to do with high pressure systems. So if we go to the learning goal page here on high pressure, and we scroll down, we get to these contour maps that we present. So we'll focus on figure A here. And first thing you notice is that there's these lines. Now I'll refer to these lines as either lines or contours or their technical name, in this case, which is isobars. That's here. Uh, Iso means equal, and bars refers to the pressure. So these are lines of equal pressure. So if we look at this line, for example, which is labeled 99.6 kilopascals, where kilopascals are pressure units, anywhere along this line has the same pressure of 99.6 kilopascals all the way around this whole contour. This line here is labeled 100.0 kilopascals, so that value is slightly higher. So this anywhere along this line is a slightly higher value of 100.0 kilopascals. Similarly, this line is labeled 100.4 kilopascals, so we have even a higher pressure. So that's what these isobars or contours mean. They indicate some sort of constant value. In this case, they're indicating a pressure. In this case, they're indicating a constant or equal pressure value anywhere on that line. So then we want to figure out how to use these to identify high pressure systems, and later on you'll learn how to use them to identify low pressure systems. On this map, there's a nice H there, which tells you that this is a high pressure system, but on real world pressure maps and some that we present later in this course, there aren't going to be any letters to identify high or low pressure systems. So what we need to learn how to do is interpret the values in between the contour lines. So since we have 99.6 kilopascals here and 100.0 kilopascals here, you know that pressure is increasing as you move from this line towards this line. The other thing that tells you is that anywhere between these two lines is somewhere between 99.6 and 100.0 kilopascals. It would also be a reasonable assumption to make that about halfway between these two lines would be about 99.8 kilopascals. So now if we continue that reasoning, we can see that pressure is also increasing as you move from this contour line to this contour line. So we begin to put together the pieces of the puzzle here, and we see that pressure is increasing as you move in this direction towards the center of the innermost concentric circle here. If you analyze it from this direction or from this direction, you'll see that anywhere you move towards the center of the circle, we know that pressure is increasing. So that means there must be a maximum in pressure at the center of this inner circle. So that's going to be our high pressure center, which is the maximum in pressure. Likewise, if you move away from this center in any direction, you'll see decreasing pressure. The last concept to talk about is gradients. So again, gradients, we can use that in terms of pressure. We might also use that in terms of temperature. But a gradient refers to how tight or how tightly together the contours are spaced or how far apart they're spaced. So if we move at some constant speed, moving away from the high pressure center in this direction to the northeast, you can see that the pressure values change relatively slowly with time as we move away. Now, if we move towards the south at the same speed, you can see that the pressure changes more rapidly with time, from above 100.4 down to 100.0 and then to 99.6. So this tighter spacing means that pressure values are changing more quickly if you move away from the high pressure center, whereas in this direction, where we have a relatively weaker gradient, the contours are spaced more far apart, and if you move away from the high pressure center, the values will change more slowly with time.